Welcome to another exciting ECE 420 class. I thought what we'd do is have a little lesson on how to write a patent, because I thought that would be a generally useful thing for us to know how to do, or at least have a basic idea on how to do. And so what I would do is I would present for you some basic background on writing a patent, and then what I would do is I would show you an idea that I had, and then I'll show you what I can do to take that idea and claim it as my own with the United States Patent and Trademark Office. And so before I get into that, did we have any homeworks due today, and did you all have a chance to do it? You did? Okay. And did you upload it to Axiom?
There were like a small modification I did, so I uploaded it twice.
You uploaded twice? Oh, I don't know. Yeah, I uploaded twice. Whoops. D-Lion. Okay, so let's see what happens when you upload twice. Something bad, I imagine. Let's see. So I've got student assignments, and I guess it would be this, right? It's this one here, the patent search. Is that right? Okay, so then if I click on that, hello, come on in. We should be able to see student files. There we go. And sure enough, here are the student files. So this is uploaded today. Very recent stuff. And it looks like I've got stuff from... What happened to Robbie? Students with no files. There's no homework here. What happened? You didn't upload your homework? Yeah, it's this one? Sporty. Sporty didn't upload. And Chitan didn't upload. Now, Raul, what happened to you? You uploaded like 3 times here. Oh. Well, now let's see. Which one do I use? This one here, I think. Are you sure? Maybe you'd like to upload again. Okay, well... Huh. What is going on? Open. And this is the Witricity project, right? Okay, good. Oh, wait. There's tools here. Would you like to present your work? I think you should. Because if I present it, I don't know what I'm doing. So why don't you come up here, and then you can talk into the microphone, and you can present. Okay?
Good afternoon, everyone.
Anybody wants tea? I've got tea.
So, good afternoon, everyone. My name is Rahul, and this is my topic, which is...
Speak up, project, like you mean it,
Yeah.
enunciate, breathe, sit up straight, breathe from the diaphragm. You're addressing an audience.
And my topic is Witricity.
Oh, and don't be nervous.
So, the name itself is like combination of 3 words: wireless transmission of electricity. That is the whole meaning of Witricity. WI in the sense wireless, T are transmission, and the last four letters it's electricity. So it's a complete combination of three words. It's wireless transmission of electricity. It's called Vitricity. So as I said, the main concept of the topic is like transmitting the electricity wirelessly. We don't in the topic we can transmit the electricity without the man-made conductors to a distant places, not far enough, but it will be like useful in the homes and offices and the buildings and many other commercial places also. So the main question that would arise is like, why don't we just use the wires? Why are we going with the wireless electricity, which is like the complicated thing? So you can see the first and most important reason is it is difficult to maintain. If there is any problem in the middle of the wire, we need to replace the whole wire. We need to chip off the ceiling, break the wall, get the wire out, fix it, and then again fix it into the wall. So it's like a lot of man work, and so it's like difficult to maintain. And the second thing is like, while repairing it's like a tough job. The electricians or anyone may get an electric shock and they may even lose their life, so no one wants to do that. So using this wireless electricity concept, we can make life easy. And the third is, at the time of storms and all those things, it may produce fire hazards, or the wires hanging in the antennas may break and may cause electric shocks to the people walking nearby. So to prevent all these things, we can just use the concept of wireless electricity and achieve a simple life. So you can see in the picture the problem. So no one knows which wire leads us to where. It's like very complicated for anyone to repair and replace a wire or anything like that if there is any issue with the wires, with the electricity. So using this wireless electricity concept, we can just make life easier and simple. So probably if we implement this Vitricity concept, we will expect some advantages, some easy things. So the first and main thing is like low maintenance cost. It doesn't need a lot of resource like the plastic, the copper and all those things which are used in the wires to transmit electricity. And it's comparatively fast, but not with the faraway distances. In the short range, it's very fast to transmit the electricity, and also it is eco-friendly. The birds, trees and nothing gets infected or gets into trouble using the wireless, using the Vitricity concept. So the basic principle on which the Vitricity concept is implemented is that when two objects are having the same resonant frequency and are also in a very strong magnetic field, magnetic resonance, they have the capacity of transmitting the electricity from one point to the another, from one coil to another coil, while losing some with the off resonating objects. So by using this principle, we can achieve the concept of Vitricity. And this is like the simple thing how it works. Well, you can see in the picture. The whole part is like the enlarged thing of this thing. So this is one of the magnetic coil. Let's assume like an antenna A, which is housed at one of the place in the house. So when we pass electric current into this coil, it produces a magnetic field. And you can see here a man using a laptop. So there is another copper coil which is like under his laptop and is plugged into his laptop. So assuming these two coils are in resonance and are in magnetic resonance, these two tend the capability of transmitting electricity, by which means we can transmit electricity from one place to another wirelessly. So here is like a small video. Shall I? Can I play the?
Okay. But I'm still not clear on what your contribution to all of this is. This sounds
Like-
like a description of what exists already.
Run an electric current through a coil of copper wire, and the coil will produce a short-range magnetic field. Place a second coil within this field, and an electric current will flow through it. The magnetic field has transferred electrical power from one coil to the other. This principle is called induction, and it has been understood for more than a century. Induction is what charges a wireless electric toothbrush, for example, and it works well over extremely short distances. Pull the coils apart, and the power transfer ceases. It turns out that the trick to longer distance power transfer is the same principle an opera singer uses to shatter a wine glass from across the room. It's called resonance. For the opera singer, when the frequency of the sound wave matches the unique resonant frequency of the glass, the acoustic energy is converted to kinetic energy at the highest possible efficiency. The energy then builds inside the glass until it shatters. The coils that Witricity uses to transfer power wirelessly are magnetic resonators. First, a rapidly oscillating electric current is applied to a coil at a specific resonant frequency. This creates a magnetic field in the region around the coil. Tune a second coil to the same resonant frequency as the source, and it will couple, resonating anywhere within that region and converting the oscillating magnetic field into an electrical current within the second coil. This response is called highly coupled magnetic resonance, and it hasn't been done before. By attaching the second coil to a device, such as the battery of an electric car or a mobile phone, this current can be made to do useful work. The source can be either centimeters or meters away from the device being powered, and can deliver power through walls or around metal obstacles. The power can even be distributed across multiple devices at once. So by a simple trick of physics, power is transferred wirelessly.
So, what frequency does it operate at?
Like, we can set it actually. Like, the both should be in
Can
a
it be any frequency?
the radio frequency, the range of the radio frequency.
Can it be terahertz?
Not much, not too high.
Well, what's a
So-
good range?
Like, it depends on the power of what the equipment needs.
100 watts.
For the 100 watts, it will be like okay. For if it is for 100 watts, we can adjust the frequency such that both the coils are in resonance, and it
So what's
treats
the frequency?
it actually operates on the under the range of radio frequency, like
You mean like 100 gigahertz? That's a radio frequency.
yes, 100 gigahertz.
It'll work
But
at 100 gigahertz?
it might actually,
You don't know. You
I did
can
not
say
go
you don't
through
know if you don't
yeah
know.
I did not go through with the power.
I think you better know what frequency it operates at.
Okay,
And also I think you better find out what your contribution is to the field. Because
okay.
so far it just looks like you told us what exists, but you haven't told us
So
anything.
this is the Atmel AVR, so we can power it in by putting the copper coil just beneath it, and we can just use the microcontroller.
So
anywhere in a
are you
room.
proposing a device that works specifically with that device?
Yes,
And
for
that's your contribution?
yes,
Ah, okay. So you're going to make a wireless
this thing to work
powered
wireless.
microcontroller that you can put somewhere, perhaps for a wireless application.
Yes,
So
so we can just put the
use
source.
electricity to power it, and then you can have Wi-Fi or Bluetooth.
We can
or
use it
something.
anywhere.
Ah, I love this idea. That sounds like an invention. You could sell that. That's a Kickstarter project. Very good. I love it.
So we can just put the source in one of the room or office wherever you are using it, and we can use the microcontroller anywhere in the surroundings.
Yes, it's much safer because you don't
Yes.
have to couple directly to, if you have a biomedical sensor on this, you can attach it directly to your skin and you don't have to worry about electrocution because you're using electricity to power it.
Yes.
Ooh,
And even the man and the tissue doesn't get affect with the wireless electricity.
good
The,
stuff. I like it. Very nice. What else?
so yeah, that's it.
That's it?
Yeah.
Very good. Thank you.
Thank you.
All right, let's do your thing. Is it warm in here? I feel really hot. All right. So distance learning means I don't have to be hot. Because if I had distance learning, I could be doing this outside. Where's the student work? Uh. Empty? Huh? Do what now? It's this one? It's this one. It's this one. I click here, right? Okay. Documents? Oh, student files. Ah, thank you. Actually, I could probably just download the whole thing at once. But let's do this. George, you're up. Open. And there you go.
Yeah, good idea. Okay, my name is George Reynolds, and I will be presenting on my project Ferromagnetic Materials Detector slash. Sorry, I will be presenting on my.
The diaphragm. Audience.
Yes,
Say it, say it.
I will be presenting on my my idea of ferromagnetic materials detector slash sensor, and it has to do with. Before I start, I just want to get where I just want to get. I want to find out from the audience how many of you know about this project has to do with maglev, magnetic levitation. How many of you are aware of this technology? It has to, like magnetic levitation, meaning like for example in China they have a train that's powered by this. Do you are you aware of this, or do you know about this? Okay, well my invent has to do with So basically, it's been widely used to. One example is in the maglev trains in China. They're powered by repelling magnets. Since I decided to come up with a new one, it has to do with
George, take a breath.
Yes, sorry.
Relax. We're all friends here. No reason to be nervous. Just sort of, close your eyes. You're on the beach.
Yes.
Take a moment, and then gather yourself, and then start.
Yes, I'm sorry.
Take your time. Don't rush.
Okay, so the problem that I'm dealing with is travel. This is kind of a futuristic a futuristic use of maglev. Basically, it has to do with traveling outer space, going through asteroids and basically coming in contact with can someone go before me? Can I
You want to
take a little minute? Yeah, someone else to
Absolutely.
gather my thoughts. I apologize.
It's okay. No reason to apologize. One of the things that we want to have as an outcome for this class is the ability to do presentations comfortably to others. And sometimes I think what happens is people find that it is a very common fear, to the fear of presenting to others. But if we need to move our careers forward, the ability to present our ideas to others will serve us throughout our adult professional careers. And so it is a part of both oral and written communication that we be able to pitch our ideas either to investors or to management. And so as a result, if we cannot do that, we cannot take the lead, the technical lead, which means we will always be doing what others tell us to do, and no one will ever do what we think of. So if we want our ideas to have impact, we have to be able to present them well. Sometimes, even a bad idea presented well can be acceptable. So it doesn't necessarily mean that your idea is good or bad, but if you couch it in poor presentation, people will not take it seriously. It's not fair, but it's often true. Who's next? Alfredo's not here, but I guess we could play his thing. I guess. What happened here? Wait a minute. And here's another one. Open. Whose is this? That's yours? You want to present it? Okay.
Hi, good afternoon. Last week I presented some of my ideas. Those are multiple email forwarding in Gmail and motor design advancement in using neodymium iron batteries, magnets, So I did lot of patent search for these two, and for electropermanent magnet based motors, patents are lot are available in Google patents. And when I talked with someone like Professor Reinmunden about this multiple email forwarding, he said like it's not a it's obvious thing. If Google wants to do that, they can do it like that. So I thought it's not a better idea. That's why I'm moving to other idea. It's like advanced airport security using RFID. So advanced airport security using RFID. You guys know RFID, right? Radio frequency identification.
Yeah, they power it with electricity.
Exactly. So we have at airports, we can see we are all like so many of us. They are international students. We are all done this baggage checking and immigration checking. There's lot of lines over there, that to check the baggages and everything. So current security system, it's a like risk-based approach. They check only particular items like guns and firearms or liquids and any sharp knives and sharp objects like knives and all. So using like when we get the gate pass at airports, boarding pass like that, if we attach some RFID something RFID tags to that boarding pass or something else, something to that, so we can track all the passengers record, and if we attach that one to the employees who are working over there, we can track all of their information by using RFID. So what's the basic motivation of this? Like it increases the security levels, because we can see like public threats are more like terrorism and everything. So to track passengers and employees continuously, we can use this RFID. So why I'm choosing RFID means it's the frequency. By using RFID, it's portable database, and RFID tags can't harm the humans, or if we attach human body, it won't harm the people. And long read range, we can transmit signals from system to that RFID tags, very long range. So what's the method I'm going to use? Like I'm proposing this one because this method uses RFID tag to store the predetermined data, and RFID reader transmitting receiving from RFID tag to the gateway. So I just did some patent search and everything. So I got like we need hardware for this: RFID tag, RFID sensor, gateway, and personal computer. All this hardware we can use that. So I did some of these patents. Like we have RFID control parking system. In this one, like we have some RFID and we have electronic device RFID tag that's embedded in cars, so that the car can, like when we enter in the parking area, the car can enter in the parking area. They keep all the records of that. And we have portable handheld security system. It's like it's a kind of security. Wherever we can take it, like we can identify that electronic device where it goes.
So what is your contribution to all of this? What are you doing that's different from what exists?
So I'm going to do like database storing. If we propose that RFID parking system in airport, how we can do that?
What does RFID parking do?
We have a RFID tag in the cars. Like we build that, we put that one RFID tag in cars so that we can track that car.
Why do we want to track the car?
When it enters the parking lot and when it exits the parking lot, it's the RFID uses, like we use that one for basically security purposes, to track the electronic devices or any kind of thing.
Isn't this what EasyPass does?
EasyPass?
EasyPass is an RFID system that you put on your windscreen. When you go past the toll booth, they don't charge, you don't stop, they charge your account. So they can identify the car using EasyPass.
EasyPass, yeah, that's like, I think those are based on electronic, license plate identification, right?
No, you have to have, it's based on what you have, an RFID system. EasyPass identifies the car uniquely using RF. drive through the toll booth at high speed, and then they charge you.
So I want to do this one for airport security, so that like whenever we are entering in the airport, they give you pass with that RFID.
So Easy Pass is used to, what, you want to charge people like for parking using Easy Pass? No?
I don't have any idea about Easy Pass.
I'm still trying to get at what your system does that's different. Are you trying to get long range RFID? Is it better performance somehow?
Yeah, is it like this? This is like we can track all the if we have an airport like big airport like JFK, like we can track all the members like where they are going. So we have restricted areas in airports. So to track all the information of where they are going and all those.
I think it would be very good for inventory control, because people want to track product at the case level. You can have RFID tags that work through metal. That would be very good. But what I find from Pepsi Bottling Group is they are not able to track at the case level because RFID tags don't work down there. If you can make RFID tags work at the case level, then you have product that Pepsi would be very interested in. I'm not sure how would you sell this product, and where does it impact, and why do I need it? I'm not sure about this product yet. So your contribution is you're just going to take RFID tags and put them on cars.
And we need to put in database, like we need to track all the information from there. We have a gateway at the personal computer.
I think your idea needs work. So you can work on it, sir. Thank you. Okay, who's up next? I still like your magnets for the motor. You can. I don't see anything wrong with the magnets. Yeah, but you're going to build a better one, right? Leaf blower. Well, no, you have to find out what it means to build a better one. So let's see what happens here with this.
Engines used in motors generate noise due to combustion. Typically, the noise generated.
Let's make it a little louder.
Engines used in motors generate noise due to combustion. Typically, the noise generated is suppressed by a muffler system or by the use of noise-absorbing materials. But these techniques obstruct the free flow of exhaust gases and reduce performance. A leaf blower is a gardening tool that forces air out of a nozzle to move yard debris. The new accessory that I want to implement reduces noise produced by two-stroke engines. My approach for this problem is different. This project involves the study of an active noise cancellation device that is going to reduce unwanted noise from engine motors in a leaf blower. my motivations for this project. Reduce permanent or temporary hearing loss. Lack of situational awarenesses. And reduce fatigue and headache due to high noise exposure. The impacts of this project are reducing the overexposure to temporary or permanent loss of hearing, eliminate or reduce vibration parts, and eliminate engine noise. How is this achievable? I need to learn and understand the amplitude and phase of sound waves, analyze an engine motor sound, design a noise cancellation speaker, and place the cancellation source very close proximity of acoustic disturbance. These are my sources. An active noise cancellation apparatus for a motor vehicle by Gillis. Wide area noise cancellation system and method by Brown. And active noise cancellation by Curtis.
Okay, so it looks like there's a need, right? Leaf blowers are very loud. Maybe it's possible to make it so that leaf blowers could be muffled with mufflers, and pretty soon I think we can envision almost all small engines have mufflers so they become incredibly loud. But then the question becomes, what can we do with active cancellation that's going to be different than what others have tried? Very difficult problem because you have very high power in the pressure wave from the explosion of the gasoline, and we have to somehow detect it and cancel it with something that's exactly out of phase. That's called destructive synthesis. You create a sound that is exactly like the sound we're hearing, only it's out of phase by 180 degrees and causes it to cancel. This is the active noise principle. It's very difficult to pull off when you get far away from the sound source, but if you are inside of the exhaust pipe and you have a pressure transducer, it may be possible to both sense and emit the sound in relatively short intervals, especially intervals that are synchronized with respect to the firing of the combustion in the combustion chamber of a motor. So, Alfredo and I had discussed this on the phone. I thought it was a reasonably good idea. There's a lot of, I'll call it, innovative stuff that you have to do to take an idea, turn it into a prototype, and then take it from a prototype and make it into a product. Lots of engineering involved. And so there may be a contribution in the engineering there, because in terms of the physics, the principles are very well understood and very easy to envision as working properly. But in terms of a real device that you can turn into product, it's very hard. It's very tough. And nobody does it, as far as we know. So that makes it for a contribution. Now, who else do we have here who hasn't gone? We've got George, you're back up. Raul, you already went. Alfredo went. I'm missing Chitan and Sporty. And you know you get 10 points per day late with these things. Nothing, huh? George, you want to try and come up again?
I'll come down.
All right, so what we'll do here, George, open, and say goodnight. You're here, and ready?
Go again, yeah.
Okay.
Okay. Hello, I'm George, and I will be presenting on ferromagnetic materials detector. That's the name of my project, and it's based, like I said at the beginning last time, on maglev, magnetic levitation. So, my problem, I looked at I looked at this problem from a different angle. Most of what maglev is, law of magnetic levitation is used for transportation problems. Like I mentioned, in China they've made a train from basically repelling magnets. And basically what's really good about magnetic levitation is the fact that there's very low, almost in some cases no friction involved. And so that with that, the train, for example, can go almost 300 miles per hour. So I looked at my problem was I looked at outer space, like travel in outer space, and so this is not really this problem. Just say right now is not may not be possible in the next few years. It's just a kind of an idea I had with maglev, a new idea. So basically, how my system would work, it would be used for on a spaceship to detect ferromagnetic material in the in the path. For example, if you were traveling through asteroids or meteorites, the magnets would be able to detect the would be used to detect the presence or trajectory of ferromagnetic material in asteroids or meteorites, for example. So the motivation for this would be, of course, to avoid collisions with rock-like objects in outer space using principles of magnetism. And then, all right. So why would this problem be important? Well, if mankind is to next stepping stone would be to go to Mars and beyond, and obviously, of course, to get there you would have to avoid the asteroid belt, and other obstacles would be in the way. So this device would help detect those rock-like objects. So my approach to the problem. Okay, so the ferromagnetic material will be, that is basically a fancy word for magnetic, will be detected by the magnetic field of the sensor. The sensor will be connected to the spaceship's navigation system and will help guide the ship to avoid a collision. And of course, if the ship gets too close to an asteroid or another obstacle, the maglev system, that is magnetic levitation, will kick on, and the sensor's magnets will repel away from the surface of the ferromagnetic material. This, of course, these magnets will, of course, have to be very strong in order to sense, in order to repel the rock-like material. So like I said, it's not really, it may not be feasible right away. There will be a lot of research, and I can't give you a price for it because it may initially cost a lot. But once some research goes into it, it may the price may go down. But and these are my I didn't find my particular device was not on the couldn't find a patent for it on the U.S. Patent Office or the Google patent, so I thought it was a fairly good idea. Just some further research we'll have to go into it to figure out how it will be used in the future. I know it's not very clear, but do you guys have any questions or anything you'd like me to make more clear for you?
So is this a magnetic levitation travel system?
Well,
push away objects?
It's basically push away objects, because that's what magnetic levitation is. It's basically repelling of a magnetic field, and so this has already been used in wind turbines to make them more efficient. Wind turbines, for example, flying cars, like they would have most of these systems have, well, in the case of a flying car, or it would be like a pod, and it would have a guideway, and basically it moves along through magnetic, repel and attract. It's basically how it works. And it's really efficient. well, it's really fast because it's the friction, like I said before, is very low, and the air drag can be significantly reduced.
So if you're in space
Right.
and it's cold,
Yes.
can you make superconductor magnets more easily?
Yes, you can.
So that's one of the big advantages of using it in space.
Correct. Yeah.
You can make extraordinarily powerful magnets, and you don't
Right.
have to have the extra energy needed to cool them.
Exactly. Yes. So they're already being cooled as is. But I mean, obviously, this is not something that can necessarily be created right away. You know, this is kind of the long-term thing, and
You're basically proposing a force field,
force field.
magnetic force field.
Yes.
That repels objects in space
Well,
in order to protect the spacecraft.
Exactly. Yeah. And so it's just another use of the. I thought it was a pretty creative use of the maglev system, even though it's not what you typically hear. Being mainly used for transportation, but so I don't know. Any questions? Anything that you'd like to for me to make more clear?
So magnetic force fields don't exist in the patent literature?
Well, they do. It's not the use I'm looking at. Like they're meant. A lot of the use for them are for the transit systems, like for the rails and for the components, but not my particular use. No, that's why I.
Can the magnetic force field deflect cosmic radiation?
I believe it can, if it's.
So that's a big danger going to.
Well, if it's. Well, yeah. I mean, I'm saying that this is not necessarily. Obviously, a lot more research has to go into it before. It's not feasible right away. That's kind of my disclaimer on it. Yeah, and I mean, it would have to. And these magnets would have to be huge too. So it's.
So it's a superconducting magnet in space used to create a magnetic force field to protect the spaceship.
Yeah, and to repel, objects. These asteroids.
Magnetic rays.
Yes.
All kinds of things that you can influence with power.
Right.
High power. You can levitate a frog with a super magnet.
Right. I know. Yeah.
It doesn't have to be ferromagnetic. That's very interesting. Thank you.
Okay. Thank you.
So is that it? Okay. Let's take a little break and then we'll set up for the next phase of the lecture.